So if you want to, this is the same way it's defaulted to in Rhino. So for our lofting, what we're going to do is take this curve and loft it to that one to begin, and then create another component and loft this curve to that one. Delete this. Just a series of planar surfaces. Oh, no, my apologies, that one's not it. This one to this one. Oh, that was it. Yeah, that one to that one. So now we have our three top surfaces that we can work from. Now if we were to do this bottom one, because it's an equilateral triangle, we can very easily loft this curve to this curve and get a complete surface. So what this means is if we have one closed polyline here, we would have to pull out these individual informations. So you could use, one way to do it would be what's the name of this one? I never remember. Surface, no. Where are you? Deconstruct prep. I always want to say decompose. So if we did that and we pulled in our, what it's asking for is a geometry or any kind of brep, which is a boundary representation, to be inputted, and then output is faces, edges, and vertices. So it's going to give us all this information for this one. If we put a panel into our edges, what you're going to see, hopefully, yes, is a series of 3 curves. So if we were to use list item and call out, this is a very long way to go about this. If we were to do list item of our edges and then put a slider, we could start to call out. I'm going to hide these for now. Highlight our lines. So at the second index in our list, which is the second curve, it's this line. You can see here. For the first index, it's that line, and for the third, it's this line. So we could call out that one, and let's say the second one. Disable this preview. Highlight that one. So I'm going to do a loft between that curve and that curve, and put these into our lofted component. And then because the information is flipped, it's not working great, so I'm going to try the third one, and nope. So right now what's happening is that that curve and this curve, like, because they're lofting past that midpoint, they're doing the same thing they would in Rhino, and that surface is inverted. So let's see if we bring on the flip. Plug this into my surface. No. Surface to flip. Let's flip our curve. I'm going to flip this curve and then feed it back in, and then remove this, and it works. So what I did was flip those normals on that curve, which is if you built this in Rhino. What this looks like is this. If you turn on your directions, you're going to see that every curve has a direction, a start and an end point, so it's the magnitude and direction the normals are running. What's happening with this one in Grasshopper is, if that ever occurs to you, is that those normals are flipped. So what you need to bring into is the flip curve, and it'll adjust these so that you can loft things together. So that's one long way to do it. The other way is to check out our surfaces and see if we have any let's try boundary surfaces to begin with. So if instead of, I'll delete all this because it's not necessary, we have that curve. So now if I put this into edges, what we'll get is a planar surface, because it's resulting from the edges that we've fed in. So it's a series of curves. So that's a much more simpler way to do it. So if you were to turn these all on, You could then bake all these and then get the same kind of output as we did with the 4-point surface.